So we're here to talk through this consecutive pairs Sudoku by Murat Can Tonta. It has very few givens, which leads to some of its challenge. It also, from the givens which right now start touching dots, it has none of them that have any quick deductions as a consequence of the numbers around them. And so this really requires us to take advantage of both a feature of consecutive pairs puzzles and the specific geometry of this one. And so a feature is you'll often see connected sets of cells that are runs. The runs can sometimes go between boxes. In this case, the runs are in the four corner boxes. They're 5 long. When runs are contained within a box, they'll have to have a series. In this case, a series can be 1 to 5 or 2 to 6 or all the way up to 5 to 9. But each of these runs will have a 5 in it. And in this upper left box, we have a pretty easy way to start, which is because a 6 is not in the run is 1 to 5. The 5 is going to be in one of these corner cells, a 1 in the other cell, and 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. And we can get started by actually placing an 8 into this cell, a 7, 9 in the remaining 2 cells, and go from there. The critical placement of this 8 now forces the start of a chain around the corners, and it starts by actually thinking that the 8 has to go somewhere in these 3 cells. It can't sit in this bottommost cell. That would force a run to go 9 to 10, out of scope for a Sudoku of this size. So there has to be an 8 in row 7 or 8. This then is going to have a run that comes down with a 7 in these cells, a 6 in these cells, a 5 in these cells. You'll notice if you've seen me do Sudoku puzzles before, I use these either-or notes all the time. And one of the nice things in a consecutive pairs puzzle is with these dots, these notes all chain together. So if an 8 is down here, 7, 6, 5. If the 8 is up here, 7, 6, 5, they will move all en masse, which means in practice, this cell can only have a 6 or 7, this cell can only have a 5 or 6, things like that, or things you'll see. For this puzzle, the key interaction is to recognize that having a 5 in one of these 2 cells is going to force a chain around the whole rest of the grid. A 5 in one of these 2 cells means a 5 is in one of these 2 cells. Remember, we said at the start that with a chain of at least 5 connected cells, a 5 has to appear in it. So 5 has to appear in this space. A 5 has to appear up here, but it can't be in these cells. And going around the grid here to here to here, we get that the 5 must be in this cell, which gives us the rest of these placements fairly quickly. We can now start to work a little bit into these other spaces by considering the specifics of what the chains can be, and that we have a 7 in the cell says that this 5 can't be coming up. If this was, it would be 5, 6, 7, 8. So this has to be coming down. The next pair is going to have a 3, 4, then a 3, then a 2. These now place 2 4s into the rightmost columns, which means a 4 is over here. What that means is this 5 can't be a 4, 3, 2 coming down, although until we'd marked a 4 over here, we wouldn't be able to recognize this. You can now see that this is a 5, 6, 7, 8, and could have some extreme on these sides. We already have an 8 in this row, which means that 8 pulling everything down like this is what's true there. We now finally can make a deduction about this cell that joined at the start. The 7 eliminates digits to the left, makes that option just have 1 left. That completes this with a 1 and 3 left over. We can go ahead and, having placed this 2, come down to this bottom corner and see that that now pushes this chain over this way. Again, very quick progress. The 9 also forces this, 6, 8, this 1, this 3. The remaining digits in this space are a 7 and a 3. A 7 would force a 6 or an 8 in the cell. Both of them aren't possible. So the 3 has to be up top. This is a 2 or a 4. The 2's already in there. Sorry, the 4's already in there, so this is a 2. We still have a fair bit to work around, and it seems that this is a good place to start to get into this corner. We've done a lot of things around the other corners, and so some things that you can recognize. A 3 is in one of these cells. A 1 is in one of these cells. A 2 is in one of these cells. We can recognize a 3 is down here. It looks like the right place to make progress is recognizing we have two options left for this. If a 1 is in the cell, it would need a 2 right next to it. That's not possible, so the 1 has to dodge the consecutive pair. This 4 wants a 3 or a 5. The 3 is already there, so this is a 5. That makes this a 7. The 5, looking over to the right, needs to be placed in this column still. It can be placed here and no other spot. That now limits this remainder of the space like this. You get something like a 4, sorry, a 5 is in one of these cells. A 4 is in one of these cells. You get a 4 up here in the space. This top space has a 7, 8, 9. It needs to connect to one digit, one smaller, and that run is 7, increasing up. The smallest digit in the top is the one that has to be used, and it connects down like this. 2 and 5 are left in these cells. 5 and 5 has to come down and place a 5 here. This is the only space that's allowed for that. Let's just use this 2 and this 2 and try to just get a 2 in this corner, recognizing that's going to force a lot over here. If the 2 is in this cell, the 1 and 3 right under it would be used by that dot, so the 2 has to be to the top. To avoid that situation, that places all of these. Again, the either or notes quickly give us progress. This 2, 2, 4 now is exactly a 4. That says that this run is 5 to 9, and the 9 has to be at this extreme. We get this run very quickly. This 8 forces this space. It leaves the 6. The 3 has to push up. The 7 is all that's left. 7 and 7 eliminate. You see a 7 is here and 8 is here. A 1. The remaining digits here, 9 and 4. The 4 is up above, so we can place these. We need to get an 8 into the center box. It has to be here. It's going to connect to a 7 or 9. 9 is the only thing that's really left for it. Just seeing this column has a 3 left over. Need a 6 is the only digit that's left that can touch to this. This is 1 or 2. Got 2, 1 there. 2's got to come into the center. That's going to come in here. 9 forces 9 and 1. Remaining digit of 6. Remaining digit of 1, 4, and 9. And we finish this puzzle. It's actually fairly easy if you both take advantage of the notes, which clue some of your thinking, and particularly clue into the way the 5s work around the grid. That a 5 in this column pushes a 5 into this row, pushes in that column, and so forth, going around. And so you'll see a lot more of these consecutive pairs in the upcoming The Art of Sudoku 2. Again, a way to think of these cells in common or together, sometimes even thinking about the parity. If this is an even, then 2 away is another even, 2 is away another even. You'll come up with some of these rules about the interconnectedness of cells, and that's one of the reasons we really like this style, is it adds those constraints nicely into the grid. So we hope you learned something through this puzzle, and we'll see you again soon.